Now let's see the basics of binary number system. Okay, see, binary number system is very important coming to computer science. Okay, if you are very good at binary number system, it comes very handy not just for operating systems. You go for any computer science subjects, whether it be computer networks or computer organization architecture or any subject. Okay, any computer science subject, being very good in binary number system is very helpful. So I just go through the basics of this. Okay, what is meant by binary number system? First, let's see what is meant by a number system. Okay, what is meant by a number system? The name itself suggests, right? See, in case today we are actually counting using something called as decimal number system. Okay, these are various types of number systems. Today we are actually counting using decimal number system. What does it mean is, you write any number, for example 593. Okay, you take any digit. Okay, you take any digit, all of them will be in the range from 0 to 9. Okay, that is what we mean by decimal number system. See, 0 to 9 we have 10 numbers. Okay, it is not 9. Since we are starting from 0, there are 10 numbers. Hence we say this is a decimal number system, or also we can say that base 10 number system, or we can also say this as radix 10 number system. Okay, radix and base both are same. Okay, either we can say this is base 10 number system or radix 10 number system. Now apart from the decimal number system, we have lot of number systems, like we have something called as octal number system. Okay, octal number system. In octal number system, every digit of your number should be in the range from 0 to 7. Okay, from 0 to 7 there are 8 numbers, and so this is also called as base 8 number system or radix 8 number system. Okay, it is also called as base 8 number system or radix 8 number system. Then we have something called as hexadecimal number system. Okay, hexadecimal number system. Coming to hexadecimal number system, we have numbers from 0 to 15, and so we say this as base 16 number system because it has 16 numbers from 0 to 15. What does it mean? You take any number in this number system. A number is nothing but a collection of digits, right? Digits or bits. Now let us assume each one of them is a single digit. Okay, now every digit, any digit you take from this, it will be in the range from 0 to 15. Okay, but there is a small problem here. We represent from 0 to 9. We represent from 0 to 9 as it is, but coming to 10 to 15, we represent using A, B, C, D, E and F. Okay, we represent it using A, B, C, D, E and F. Why do we do this is because, see, in case if you write a number 15, we might get confused, right? See, in case if you write a number, for example 815, what does it mean? Whether it is 8 followed by 1 followed by 5, or it is 8 followed by 15. There is a confusion, right? So what we do is, we don't represent 15 using 1 5, rather we represent using F. Okay, so we don't represent 15 using 1 5, we represent it rather using F. Okay, similarly any number, A represents 10, B represents 11 and so on, F represents 15. Okay, fine, this is what we mean by hexadecimal number system. Then we have the most popular number system, that is nothing but binary number system, coming to computer science. Okay, coming to computer science, the most important system, mostly popular system is binary number system. Okay, which means it is also called as base 2 number system. Okay, base 2 number system, and so it can have numbers only 0 and 1. Okay, 0 to 1, we have two numbers, and so it is called as base 2 number system or radix 2 number system. You take anything. Okay, see, why binary number system is very popular is, you take anything in computer science, for example size of a RAM or size of a hard disk or size of you can take anything. Okay, anything you can take in computer networks. So in computer networks you can take number of networks, a number of devices which are in a network. See, I don't want to get into computer networks here. What I wanted to tell you is, anything you take in computer science, it will be a power of 2. It will be a power of 2. Okay, for example 2 power 5. Have you ever heard a RAM of size 5 GB? A RAM of size 5 GB, you should have never heard it, because such things don't exist today. Okay, because we have RAMs of size 4 GB, or we have 8 GB, or we have 16 GB, and maybe we might have even 32 GB and so on. Okay, we will be having only powers of 2. See, this is the power of 2. Why? I have already told that 1 KB equal to 2 power 10 bytes, 1 MB equal to 2 power 20 bytes, 1 GB equal to 2 power 30 bytes, 1 TB equal to 2 power 40 bytes. Okay, fine. Now this can be converted into power of 2. How? 4 we can represent it as 2 square. 1 GB is nothing but 2 power 30 bytes, right? So I'm writing it as 2 power 30 bytes, which is nothing but 2 power 31 bytes. Okay, so I'm able to represent this 4 GB as a power of 2. Okay, whereas similarly I can also represent 8 GB as a power of 2. How? GB is nothing but 2 power 30, 8 is nothing but 2 power 3, 2 power 3 into 2 power 30 is nothing but 2 power 33. Okay, similarly we can also represent this all as a power of 2. Okay, let us assume we have only one bit. Okay, we have only one bit, and let us assume we are using binary number system, which means this bit can be either 0 or it can be 1. Okay, it is not just this bit. In case if you are using 2-bit number, both the bits this bit can be either 0 or 1, as well as this bit can be either 0 or 1 or 0 or 1. Okay, that is what we mean by binary number. Okay, we also say this as binary. These numbers are in binary number system. Okay, fine. Now using one bit we can represent only two numbers, and they are 0 and then 1. Okay, similarly with 2 bits we can represent 4 numbers. How? This bit can be, see, a bit of basics of combinatorics is needed here. Okay, this bit can be filled in two ways. Okay, it can be filled either using it can be filled as 0 or 1. Similarly, this can be filled with two numbers, either 0 or 1, and both these bits have to be filled. It is not that one of the bits has to be filled, both these bits have to be filled, and so I'm using AND. Okay, and I need to fill this bit, and I need to fill this bit as well. Okay, so in combinatorics, whenever we come across a word AND, we use into. Okay, so in R, this 2 into 2 is nothing but 4. Okay, and 4 numbers are nothing but 0 0 0 1 1 0 1 1. Okay, similarly with 3 bits we can represent 8 numbers. They are 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay, there are 8 numbers. Okay, fine. Now you can actually observe a pattern here. Since we have one bit, we are able to represent 2 power 1. 2 can be written as 2 power 1, right? We are able to represent 2 power 1 numbers. Similarly with 2 bits, we are able to represent 4 numbers, and 4 can be written as 2 square. Okay, 2 power 2. With 2 bits I can represent 2 power 2 numbers. With 3 bits I can represent 2 power 3 numbers. Okay, similarly with n bits, okay, I can represent 2 power n numbers. Okay, with n bits I can represent 2 power n numbers, and what are they? They are starting from 0 1 2 and so on up to 2 power n minus 1. Okay, these are the 2 power n numbers. See, from 1 to 2 power n minus 1, there are 2 power n minus 1 numbers. 2 power n minus 1 numbers. Along with it, I am also adding 0. So it is plus 1. One more number we are getting. And so both this will get cancelled, and we are getting a total of 2 power n numbers. Okay. So with n bits, we can represent 2 power n numbers in case of binary number system. Okay. This is very important. See, this is what we are going to use in the memory management system completely. Okay, it's not just memory management system. You go for any computer science subject, advanced topics will actually need this basics. Okay, fine. With n bits, we can represent 2 power n numbers in case of binary number system, and the numbers are from 0 to 2 power n minus 1. Okay, it is a very important concept. Fine. Let us assume I am having n bits. Okay, just 1 2 3 4 5 6 exact. Actually there are 6 bits. Okay, Let us assume with six bits, how many numbers can we form? We can form definitely 2 power 6 numbers. Okay, 2 power 6 numbers. Now, in case if I choose 3 bits from this, okay, how many groups can I get? Okay, with 3 bits I can form 2 power 3 numbers. Okay, with 3 bits I can form 2 power 3 numbers. Similarly, with this 3 bits I can form 2 power 3 numbers. Okay, so I can, these 2 power 3 numbers are actually representing the groups. Okay, they are actually representing 8 groups. 1, 2, 3, 4, 5, 6, 7 and 8. Okay, they are actually representing 8 groups, and within each group there are 8 numbers. Okay, 1, 2, 3, 4, 5, 6, 7, 8. See, this 8 is nothing but 8 groups. Okay, and this 8 is nothing but the 8 numbers within a group. Okay, I have already told that anything in computer science will be a power of 2. Okay, let us assume I have a group of 2 power n numbers. Okay, I have a group of 2 power n numbers. Now, in order to represent 2 power n numbers, how many bits do we need? We need n bits. Okay, we need n bits, which means all these 2 power n numbers will have n bits. Okay, for example, it can be 0, 0, 0 and so on up to n bits. Similarly, 0, 0, 0 and so on up to 1, 0, 0, 0 and so on up to 1, 0, so on. Likewise, all these 2 power n numbers is present. Okay, now in case if I wanted to divide these numbers into two groups, okay, now how can I do that? I want to divide this group of numbers into two groups. How can I do that? I can do this by exactly choosing one bit. Okay, now which bit? It can be any bit. For example, let us assume n is equal to 4. Okay, which means let us assume n is equal to just 2. Okay, it is 2 square. If it is 2 square, there are a total of there are total of 4 numbers. Okay, they are 0, 0, 0, 1, 1, 0, 1, 1. Okay, now in case if I wanted to divide these 4 numbers into two groups, what should I be doing is I should be choosing exactly one bit. Okay, now which bit? It can be either first bit or second bit. For example, the numbers starting with 0 are 0, 0, 0, 1. The numbers which are starting with 1 are 1, 0, 1, 1. So we have divided into two groups. Okay, this is a group as well as this is a group. Okay, we have divided these 4 numbers into two groups.